Hey,
Hey, we're live.
yay, I see it again. I see you again. Okay. Okay, so let me open up the group meeting, right? Is that the one you're on?
The 15, yeah.
Okay, let me open that one. Okay. Which one are you on? Or should we just start with number 2?
We can start with number 2 because I said it was the first one for number 2, and you know why.
Interval, confidence interval, 45. Is the best interpretation of this confidence interval. I would go with the last one. There is a 90% chance that the sample mean heart rate is between 45 and 105.
I went with we are 90% confident because that's how every other answer has been written. But and it usually that's just the confidence interval is where it lies between, and that means that they're confident that it lies between the 45 and the 105.
Right, but it says we are 95% confident that the true mean. That's what was part of her videos that she showed this week or last week, that they can't know for sure. They can't be confident that the true mean is that. Like, they don't know what the true mean is.
Okay.
And they don't even know if it lies between that.
Oh, okay.
So she had said that there's 90% chance that that there's a chance that the sample mean rate is between those two.
What does yours say?
Huh?
What does yours say? Can you read it?
For
number 2.
The question?
Yeah.
It says, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval?
Okay. Just making sure they were the same.
Part of those, let me see if I can pull them up. Part of those videos that she sent out, I think it was either last week or earlier this week, they talked about the confidence interval and how everybody's getting them wrong because people assume that we know the true mean, but we don't.
Okay.
So that's why I figured that's what it was.
Okay.
That it was the last one.
Okay.
But I'm looking for that video so that I can just double check, but I remember seeing that.
Okay.
Anyways, okay, so then the next one is 3.
Right. The research.
Oh, go ahead.
Sorry. The researchers at the University of Mississippi wanted to determine whether the reaction time in seconds no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the mean is significant to determine whether the confidence interval would be reliable. They create a QQ plot of both random samples and see that they are randomly or approximately normal. Are the requirements of constructing a confidence interval satisfied? Why or why not? Okay. Well, I think it's yes.
Sorry, I'm just rereading it because I didn't fully understand it. Okay. Yes. I would say yes.
Yes, and I said, for me, the distribution of the mean for each sample is normal since the researchers can apply the central limit theorem.
But isn't the central limit theorem, isn't it has to be over greater than 30?
Yeah. I'm just getting so confused.
I'm thinking it's the second one because it says each sample is normal since the data have been determined to be normal. And part of one of the requirements is that the data are normally distributed for each group. And you can find that by viewing the QQ plots. So you can't have an accurate QQ plot if the data is not normal.
I have another saying that. Look at the next one. It says, no, the distribution of the mean of each sample is not normal since the sample size is not large enough. Because they're taking it from two different groups, right?
Right, but if they're talking about, well, that's the whole thing about QQ plots. In order to know that something works, they all have to be within that one line. Remember, they all have to be
in that little where all the data is, yeah.
But then the confidence intervals, like in the notes, and that's the thing. I guess it depends on what type of test you're doing.
Right.
Because if you're doing the independent or the ANOVA, then your part of the requirements is, I mean, it doesn't require you to be greater than 30. But if you're doing matched pairs, then your data does have to be greater than 30.
Right. Okay, and you do a QQ plot in certain. I need to go back to. Sorry, now I'm just thinking.
So they're comparing males and females. So it's a dependent.
But wouldn't that be independent because the female and the male
Oh yeah, yes. I'm sorry, independent. Yes.
Okay.
So if it's independent, then sorry, hang on one second.
Honey, they need to be shorter. I'm getting very annoyed with them. They're just in my eyes. What?
They're probably close.
No, yeah, no. I don't need to go back today, but I'm just. It's just annoying.
Yeah.
Okay. So then I guess now we have to figure out what are the requirements for independent? Does it require you to just have, the sorry, I'm trying to figure out which ones are. We have to figure out what the we have to figure out what are the requirements so that we know if it's either if it has to be greater than 30 or if it just has to be normal.
Right. I'm looking at it. State the norm. Okay, let's see here. Even though a simple random sample of days was not taken, we can assume that the number of heart attacks on one day do not affect the number of hearts attacked. Sample size is large enough for both groups, so we conclude that the sample means are normally distributed. Okay, so it says here for like independent variables, sample size large enough, and that was not taken. A random sample of days was not taken. We can assume in this one they didn't take a random sample, a simple random sample, but they assumed that the number of heart attacks on one day did not affect the number of hearts on another. I'm reading from another example. So it looks like there was only 2 requirements there, which is weird. The sample size is large, so we can use the methods without much concern about normality. It seems to me that just talking about whether or not the sample size is large enough.
Yeah, and I'm trying to figure it out because on the on those videos where he goes over he specifically always has a section where he says these are the requirements and
I
this
know,
is what he meant.
Okay, for the, you know how we were like talking about the chance, no chance, like if there's like a chance or if it's like confidence?
Yeah.
Okay, so for number 2, I'm going to read one of the things. He, in one of his things, and like I've read 2 already, it says that like we're either, he said in this one, we are 95% confident that the true difference in the means is between the whatever the confidence interval is. So there's, it says difference. Let me see what the other one said. And then this one's prepared data. And then this one says we will compute the 90% confidence interval for the true mean difference. Again, it says difference. I'm guessing that's because...
And that's what she was talking about the video, that it's the wording is what makes the difference.
Yeah. Like this one even says we're 95% confident that the true mean change in the number of trees. Requirements. The plots of land were selected random. Pine beetle data, the histogram. This is all for the paired data. And it even said difference in independent ones too. So for the mean heart rate. So then chance, there's a 90% chance that the sample mean heart rate is between. Because there's no difference. I'm going to say for number 3, I think it's no, the distribution of the mean of each sample is not normal since the sample size is not large enough. And because both of those, both independent and paired state that they should be, well, at least for the independent, it says that it should be a large sample. And so I know that this is an independent, these are independent variables because male and female do not they're not dependent on each other.
Okay.
But you go ahead.
Okay, so I found the requirements, and part of the requirements for independent sample test is the data are normally distributed. Samples are independent, samples from simple random sampling. The distribution of sample means is normally distributed for each group. For each group, check that either the data are normally distributed or the sample size is large. So, but it doesn't say like anything about the central
Limit theorem. So then we'll just take that one out. This really is only talking about, it seems to me, that in the difference of means is significant. And in the information, it says a lot about samples, like randomly sample. So I don't know. I think that
I would say that it was the confidence intervals were satisfied. That is correct. And it was because each sample is normal since the data have been determined to be normal.
Okay.
That's what I think.
Okay, the distribution of the mean of each sample is normal.
Because it just says sample size is large, but I don't know what large means. Because on the third one it says no, the distribution of each sample is not normal since the sample size is not large enough. But
right. Well, the sample size, I guess, is the 20 females, which should be above 30, or the 15 males, again, which should be above 30. That's all I'm saying. But I see where you're coming from.
I understand, but that's what I don't understand. Like, does it have to be greater than 10? Because if it's bigger than 10, then your data is. But if they want it large enough, like I would think that here they would say, because every other time they've talked about the central limit theorem.
Right. Okay.
Now on top of that, statistics can use things like sample means and condition. And the graph should be responsible. So here, go to my output. Here's an example. This is the first problem. You have to double options.
So it's a tough one. It's just number 3.
Yeah, I know.
I
I think we're thinking that we don't want to be wrong. We're just
think we're probably just like you said, we're overthinking it. I'm trying to see if any of the other stuff that we've done talks about this. And let me check if anything that we did in the preparation for, the group meeting for 14 talks about it at all.
I'm looking to see if she emailed me something. I had a question. She answered it about. I don't know. I hate this. Okay. You know what? I think
Yeah, that doesn't talk about that.
so. Wait, what was your question again? What was so I can try to answer it? I think I might be able to.
I guess my question was, which one do we like? How do we know which one it is? If it's like, is it how do we know if if the sample is large enough? What
Right.
does it have to do with the central limit theorem, or does it not? Because it doesn't talk about that in the video.
She answered that, and I'm trying to find that. Yeah, this is too far. What the heck? Maybe it's this one. Okay. For sample size, unless the problem says the data are normally distributed, we want a sample size of 30 plus so we can appeal to the central limit theorem. That's what she emailed me.
Sorry, say that one more time.
I'm going to share my screen with you, and I want you to read it.
Let me see.
Okay.
Okay.
Can you see my screen?
Okay. For sample size, unless the problem says the data are normally distributed, we want a sample size of 30 plus. So we can appeal to the, does that answer your question?
Oh yeah, and this is the part where I said it's okay if you're meeting with Cynthia at a different time so that she can get the points. So.
Okay, so then.
Does that help?
Yeah, so then I guess it's the one that we, what is it?
So then is it no, because the sample size is not large enough and it isn't appealing to the central limit theorem?
Well, no, because she says on here it says that where it says to determine, the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence intervals would be reliable, they create a QQ plot of both random samples and see that they are approximately normal. So they're telling you that they did see it was
normal. Okay. Okay.
So that's why I was thinking, yes, it was satisfied, but it was satisfied because they told you the data was determined to be normal.
Okay. All right.
But I don't know, some of these are super tricky, so.
You know, if it turns out to be no, just for some stupid reason, let's just note it down for our test. Do you agree?
Yes.
Okay, cool.
Because those were part of the questions for, remember I was telling you I was doing the review?
Right, yeah.
There's some of them that ask that question.
Oh. I hate that question. I hate it so much.
But there's no, I don't think there was a key for that review. So
okay.
I don't know how I did. Okay, so moving on to
number
4. Sorry.
Okay.
Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
I think it's the last one because we already said that they were independent because male and female are not dependent on each other.
Okay, confidence intervals for the difference of means using independent samples.
Is that what you put too?
Yes, that sounds right.
Okay, that's what I think.
Because up here they're saying if the difference of the means.
Right.
And over here it's telling you intervals for the difference of the means independent samples.
Okay, good. We agree.
Between females and males, yes.
Okay.
A researcher is interested in estimating the savings account balance of a customer at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean saving account balance of bank customers is found to be between 3,400 and 4,100. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? So I put compute a 99% interval.
That's what I did too. I agree. And I did put that because I think 99% gives you a better confidence, like becoming more confident that is like between that margin, or that you want a smaller margin of error, therefore you need to or make your confidence interval larger. So that's 99. I think that's even stated in some sort of like rule or something. Like if you want it to be larger, like he even says it in the video, I think in one of them, where if you want it to be more accurate, basically, you go higher in your confidence interval.
Well, yeah, and then I went back to the notes, and on the notes, where are you? Okay. Well, trying to see what they. Yeah, so you're using the Z in the equation for margin error is the confidence. It's the level of confidence, but
Right.
you're putting that amount on the probability portion or the area of the applet.
Okay, good. Yes. So we agree. I think I'm trying to say the same thing, but in a weirder way. Yeah. Okay. Good.
But that's what I put on the, these are the exact same questions that were on the review.
Yeah. Okay. Okay. A factory makes propeller drive shafts for ships. Say that 5 times fast. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. Stop laughing. I'm sorry. The lengths are known to follow a normal distribution, okay, whose standard deviation is 2 millimeters, calculating a 95% confidence interval for the true mean length of the shafts. Okay, so we know that they do follow a normal distribution. Oh, we have to calculate it. Haha. Okay. All right. Lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. So in this case, I guess we're using the normal probability applet, right?
No. You're doing the 1,000 plus or minus the 95% confidence interval times the standard deviation.
Okay.
And when I did that, I got one of the answers, but I don't know if that's accurate. It's just I looked through all the formulas and that's the only one that actually made sense.
And you're saying you didn't get the other one?
I got, what do you mean the other one? Yes, I got both of the answers, but there's other ones and I guess I always second guess myself. But what I got was 996.08 And then I got 1,003.92.
Wait, hold on 1 second. 1,000 plus or minus the confidence interval in decimal form divided by the standard deviation, correct?
Mm-hmm.
Okay, and our standard deviation is 2. All right, let me see. Why didn't I get... Okay, let's do 1,000 minus 0.95 divide by 2. Wait, no, I can't divide by 2.
No, you're not dividing, you're just multiplying.
Multiply
You're
by 2.
doing, yeah, you're doing 1,000 plus or minus
Yeah.
times 1.96 times 2. Here, let me show you. Do you see that up there, what I did?
Yeah, oh, yeah.
Don't pay attention to the top, I messed up right there. But, and then I added the random sample, but that's not accurate.
Yeah. Okay, yeah, I got one of the answers. Why is my... I got this. Why did I get that?
Okay, you have to multiply 1.96 times 2 first.
Right, and then divide by the square root, right?
No, not square root. You don't need the square root at all. You just need 1.96 times 2, which should get you 3.92.
Right.
Okay, and then now that you have that, now you do 1,000 plus 3.92, and that should get you 1,003.92.
Yeah.
And then you do the minus, 1,000 minus 3.92, and that should get you 996.808.
Okay, yeah, I got that.
And that's B.
Right, and then I also got the other one, which was that 100392. That's like that, right?
Mm-hmm.
Okay, good. Oh my goodness, this test I think is gonna kill me. I'm just like losing it all. This is not okay.
That, I mean, I'm afraid too, but I'm like, I have to pass. There's no not passing. I have to pass it, or I'm just done. I'm done with this class. Like, I won't be able to make it up at all if I don't get like a good grade. Like a C at least. I have to make at least a C in order to be able to stay. I have to make a C in every other test just to pass the class. But I'm hoping I get an 80, because if I do get an 80, then it shoots my grade higher, and I could possibly make a B, a low B, but I could make a B.
That'd be nice.
I know, but I'm not. I mean, at this point, as long as I pass, I don't really. It's gonna really jack my GPA, but you know what? Okay, so
okay. To assess the accuracy of. Okay, well, I think it's those two answers. That's what I got. So.
okay.
Okay, good. To assess the accuracy of laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of whatever times, and the mean, or yeah, the sample, the mean of the weight is computed. Sorry, so my hair just looks retarded right now. Suppose the scale readings are normally look at it. Suppose The scale readings are normally distributed with unknown mean. Okay, the standard deviation. Okay, how large should the sample be so that a 95% confidence interval for mean has a margin of error of. Okay, good. Oh my gosh.
So on this one, we're looking for n, because it says how large should n be so that 95% confidence interval for
Right.
m has a margin of error of that.
So we do the margin of error one, right?
No.
Oh,
It is the margin of error, but we're not looking for the margin of error. We already have what the margin of error is.
right.
We're pretty much looking for the sample. Like, what's the number of the sample? N is the sample.
Okay. Okay. Have you been doing this one? Is this what you've been doing? Is
Are you
this
talking to me?
yeah, is this the review that you were doing or?
Yes, I didn't know that this was what they were going to have, but I mean, apparently I already answered them all.
You answered all of them?
Mm-hmm. I went through each one of them, and then I even pulled up all the data for each one of them.
Oh crap. That's the other thing
Because I
forgot.
wanted to make sure I knew what I was doing.
Yeah. I don't know what I'm going to do about the test. I really don't. My SPSS is not working at all. Like, that's why I got 71% on that last exam or quiz, because I can't open it.
Can you go to like a public library and do it?
Well, then I'd have to actually download this.
No. Use. I wonder if they'll let you chat. Because you could use a Google Hangout for.
That I can do that. Well, no, because they have like no, you probably can, but I don't think. I think I have to do it in the computer room. Yeah, but the thing is I have to download the SPSS stuff. Yeah, I don't know.
You don't have access to another computer that you could do the Hangouts and then use just your computer.
This is like the only. No, like the thing. My computer won't even pull it up. Like I can use my computer for what we're doing right now, which is the Google Hangouts. But then I'd have to download the VMware on somebody else's computer.
Well, no, what I'm saying is use somebody else's computer to do the Google Hangouts and then use your computer to do the SPSS.
It doesn't even come up anymore. Yeah, it like completely canceled out like every single time that I've done it. It just says no. So I'm like, I'm screwed. I'm gonna have to tell her like it's not working.
Dang it.
I know. So I don't know what I'm gonna do now.
And I don't know if she'll let us, like, if she'll let me share just the data and not the answers with you. Like, just let you see whatever it is I get.
I'm gonna email her tonight. I'm tired. Like I just want my computer to work. Like I know what I'm doing as long as I have the data up. All these other little questions as far as what to know were really confusing, but pulling up the data is not a problem. It's just doing it is a problem. So I have no idea. I'll email her tonight and be like, there is no way for me to download something onto someone else's computer. There's just no way.
Right. Well,
No.
I had that problem and I kept borrowing my neighbor's computer and I kept doing that and I kept doing that. I was like, because like I just couldn't go out and buy a computer because I have a Chromebook. That's what I bought for school. And I had no idea that I was going to have to like download software for this class. So I had to just like cave in and I had to go buy another computer because I just like I had to be on like my neighbor's schedule. That's why like the beginning of the year was so hectic, like the beginning of the semester, because I had to like, will you be home? And it just didn't work. So I'm like, you know what? I'm just gonna
buy a computer.
I'm just gonna have to buy a computer. this other one. And I bought like the cheapest one I could find.
Okay, well,
But-
Anthony just stared at me and said he could download it on his.
Well, that's nice.
That's nice, but then I'll have to be here when we take tests and stuff.
I don't think he'll mind. Your
I-
company.
I don't think he minds my company too. Right? Do you mind my company, honey? No, he doesn't mind. All right. Well, then. See,
Then it's
like-
settled.
Okay. Okay. Well, thank you for helping me. I just don't know how I'm going to answer these questions down here. Like, are there actual questions to answer in?
Well, no,
Like in the
I
boxes?
can stay on with you and just keep going because I don't know if they're all exactly the same ones on this review. I have no idea.
Okay.
So,
Okay, good.
did you,
Well, they're
put
all
that
multiple
formula
choice, which
for
is
the-
great.
huh?
They're all multiple choice, which is great. No typing in.
No, there's not, but like in order for you to answer some of them, I guess, I don't even know why they're asking me. Yeah, like some of them you need to know. Like I don't know. Let me see. How many questions are on this thing? Oh yeah, they're the same amount of questions on that thing. See,
Yeah.
for like 26, you need to know the p-value. 25, you need to calculate the test, and you need to like pull up the data.
Yeah.
Um,
Honey.
yeah, all of these well, do you? Yeah, you have to pull them up on all of these.
Okay.
So it's okay. I'll just stay with you, and
Well, you need to sleep too, right? It's like how late?
it's 10 over here. It's fine.
Okay.
So we're on number 7.
7, yes.
So did you understand? Is it 7? Yes, it's 7. So you understand what formula to use, right?
Yeah, it's the N one, right?
Uh-huh.
Okay. The N one is. I know this one too. Hold on. I need to tell you what it is, or else I'm gonna be sad. Okay. And this is wait. Could this one be sigma technically is known? Okay. And then the sample size calculations are n equals, in parentheses, the z multiplied by the standard deviation over the margin of error, all to the second power.
Mm-hmm.
Okay. Okay, and this is gonna sound so stupid, but what is z again?
C is the confidence interval.
Right. Oh my goodness. Okay.
So it's gonna be like the 95 when you put it into your applet, which is the 1.96.
Okay.
On the notes, like when I watched the video, they
Yeah.
did this like really helpful. I don't know if you can see it. Let me see. They did this really helpful box that helps you remember like what each one of them are.
Yeah. Oh, okay. I have that written in my notes. I actually don't have any of my notes with me, but yeah, I remember that.
That's how I knew what it was. I never even went to the applet. I just grabbed it from there.
Okay. Good. That's what I will remember. I feel bad because they called me for the Google Hangout today. Did they call you?
Mm-hmm. But
I feel
I
bad,
just
but,
don't
like-
feel like I'm prepared to go on there and like I'd rather just spend my time reviewing and really like understanding the information before I go on and like
Yeah.
you know just kind of like feel like a deer in headlights after they're done. Like I don't know what to do.
That's how I feel right now.
And I
I
watched
still feel that way.
I watched the video from Tuesday, and it's
Yeah.
like I have no idea what they're doing or what, like, they don't even go step by step. They just do their own thing,
They do.
and so I was like, I don't understand. And then I saw you came on, and they didn't even tell you, like, hey, we're on this number. It was kind of like,
No, that's exactly how I felt. So I said, okay, guys, bye. Did you see that part? I was like, bye.
mhm.
It just upsets me.
But I don't know. We're gonna have to have a group. Did you see that group design thing that we have to start next week?
Yeah.
So I don't know if we have to do it with them or if we can do it by ourselves. I don't really know.
We have to do it with them. And I'm fine with that. I just, I really hope that, I just want them to understand that when I work, like, I can't, it's a restaurant, so or like a little business, like where you serve people food, and I don't necessarily get off at 4:45, you know? Like, I'm still there even till 5, even if I say it. I just wish that they would understand that.
Yeah, and like I watched other people's Google Hangouts, like their group things,
Yeah.
and like they're all discussing things. They're all like, hey, I didn't understand this, and they're all like going over it on the same page.
And you know, Corbin's really smart. He's very
He is.
and I'm thinking Lori is too. So we're just at different levels.
Right.
Like, not, I mean, like, I read when I get home at night and stuff, and like I take some notes, and you're still telling me what to do now, and I'm like so confused still. Like,
Right, because sometimes you have to go over the information and you like it's in there, you just have to pull it out and you have to be able to like because I mean, you know, and sometimes like when you're super tired, like I've noticed that when I'm really tired, like nothing sticks in my head.
right.
Like this information. Nothing sticks. I don't get it. I just don't get it. I don't get it. And I have to I have to sit by myself and I have to go, okay, I know I've read this information. I know this and this about it. So now what do I do? What do I use? Like how do I use it?
Yeah. It's just
And like I said before, I don't want to go to the group meetings and I don't want them to give me the answers. That doesn't do me any good. Like you giving me the answers, that's not what I want. That's not why I want to go there.
right.
Because at the end of the day, like I have to go and I have to take my own test and I have to take the homework by myself. So you giving me the answers, that doesn't do me any good.
I don't know. We'll get it done. It's just, I don't know.
But
yeah. All right.
I still have to check out what I have to do for next week. But okay, so did you get 7?
I've got it, but I'm trying to do the calculations.
Oh, okay. No, it's okay.
Yeah. Okay, so n is, we're trying to find n, so that means I need to do 1.96 multiplied by the standard deviation, which is, I know we have it, point, or 0.01 multiplied by 0.01 equals divided by the margin of error, which is 0.0001, all multiplied by 2. I got 392. Why did I get that? I did
You got
exactly what.
390? No.
So I did exactly what it's supposed to do. So it's 1.96 multiplied by the the standard deviation, right? Which is 0.01,
Right?
right? And then I divided by the margin of error, which is 0.0001.
Okay.
I get 196.
Okay, now 196 times 196. Because remember you're squaring it?
Yes.
I did that. I was like, wait, that's not 1960. I didn't get that. That's not right. And then I looked back at the formula. I'm like, oh, you got to square it.
You
It's
got
fine.
30. Did you get 38,416?
Yeah.
Okay, good. Okay, the mean area of the several thousand apartments in the new development is advertised at 1,200. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicions. The appropriate null and alternative hypothesis are. Oh, okay. Oh, okay. So that means that they are smaller. That's the null. Oh, no. The null is that they are 1,250 square feet, right?
Mm-hmm.
And then the other one is that they're not. So that's the middle one, right?
No, they're looking for,
I mean, the second one.
they want to they're wanting to prove that they're smaller than advertised. Because it doesn't say anywhere that they're different. They're the difference or the different.
Okay, then that means it's the first one, which is that no. That means that
Mm-hmm.
is it the first one?
Yeah.
Yeah, because that's that little caret that's facing towards the mu, right?
Mm-hmm.
Okay, good. That makes sense. Okay, in a statistical test of hypothesis, we say the data are statistically significant at the level of significance. If A is, we say the data are significant at the level of significance if they equal, right?
I put that
Larger?
it has to do with the p-value. That's what I put, that the p-value
Is
in a
larger?
statistical test of hypothesis, we say the data is statistically significant. Like it's significant if the p-value is less than 5. But I'm not sure if that's, I put like a question mark because I wasn't sure about that.
Okay. The level of significance is well, we always know that the p-value determines what the level of significance is, so I agree with you on that. Less than the level of significance. We say the data are statistically significant at the level of significance if the p-value is less than the level of significance. Is that right? The level of significance has to be less, it's less than?
That's what I put. The p-value is less than A, meaning the level of significance.
Because
so
when
that's
it's
the only way. Because if it's over, then we say that there's insufficient.
and we reject it.
We don't.
If it's
reject.
larger.
We fail to reject.
We fail to reject.
If it goes over.
Okay.
But, because see, the level of significance can really change. I mean, it doesn't always have to be 0.5, 0.05.
Sometimes it's 0.1, sometimes it's 0.01.
Right. So we know that what is true is, or what we always know to be consistent is that the p-value will be less if the p-value is less than A. Or it has to be.
It has to be because
I'm confusing myself now.
Okay, no. Here, all I need to know is when we reject and when we fail to reject. We fail to reject when it's
Over.
greater than because it's not accurate, right? or it is accurate and we don't need to. But we fail to reject, or we reject it when it's less than because we are not right at that significant level.
Right.
Okay, so then, but this says the data are statistically significant at the level of significance. At always means equal in math. Right, honey? So is it equal?
Well, the A is the level, A equals, or A, it means the level of significance.
Yes. I'm going to put a light on. Oh. Thank you. Okay, so I don't want to say less than though for some reason. Statistically significant at the level of significance. I think it's. This is so hard. I don't know. I think it's the. I think it's between the first and the second one because.
That's what I thought, but I'm like, okay, you know, we're always looking for P to make sure that we can define whether the level of significance is good or bad.
Right, and what is good or bad though? Because sometimes this level of significance is higher or lower. Good or bad just means that it might be equal to, or it could be greater than, because then we would fail to reject it, right? The whole point of a statistic is to prove whether or not it's lower than it.
Right.
Lower than level of significance.
That's why we always, the p-value pretty much is the level of significance. That's what it is.
Basically. So that means that we say the data are at p-value level at the level of significance if or equal to. I think it means that it should be equal to, because this at is what's getting me. Statistically significant at the level of significance.
But it's not at. The letter A represents the level of significance.
Oh no, I know that, but this like at right here in the middle of the sentence, I'm like reading the English part. I know what the A is. Yeah. So it says, we say the data are statistically significant at the level of significance, that little A letter, if.
Well, then let's just go with the 0.5.
Do you think it's that?
I had a hard time because, like I told you, the level of significance is not always, it changes.
Yeah.
But we know that p-value is a level of significance, and the p-value always has to be less than the level of significance in order to be able to make an accurate, or to be able to.
Well, I put the p-value was less than, but I'm not going to change that. We'll come back to it. I think that we'll think better if we just kind of. What do you? I think it's. Okay. I'll do 10. A group of statistics students wants to determine if students in some apartment buildings get better grades. Oh, I remember this one. Than students in another apartment building. They collect GPAs from any anonymous. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartments. The data of each apartment building are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can they use a ANOVA hypothesis test to answer their question?
I put yes, one, because you have 4 different
GPAs.
apartment data that you're collecting.
Right.
The other one, it says it's a bell shape, so when it's a bell shape, it means it's normally distributed.
And we can't use the central limit theorem because 15 is actually not a good sample size for each.
Right, but here it says they have a total of 60 GPAs, all 4 of them, which is accurate.
It's true.
You do.
Yeah. And they're only collecting from all apartments and doing one sample total. Yeah, but nearly equal. The standard deviations are nearly equal. The data are bell-shaped with no outliers. It is enough that the data are bell-shaped with no outliers.
At least for ANOVA, the requirements are
Right.
the data are normally distributed for each group.
Yeah. Which means that is going, I think, with this.
That it's like in the middle, like a bell.
Yeah.
Like it has to be going in the middle.
Yeah, so I think it's the first one. That's like the only one, really, so. And they even said bell-shaped with no outliers, and then they're nearly equal standard deviations. That all basically describes what a bell shape looks like. So.
Okay. Yeah, I put a question mark on that one because I was like, is it the
Well, I know it's yes, but let me see something. I think I want to know.
But it never mentions anything about, at least for the ANOVA, it never mentions anything about the central limit theorem or a large size. What it says is the populations have the same variances. Check if largest variance is no more than 4 times the smallest variance.
Smallest variance. That's in that blue thing, right? That blue box? Yeah. It's right here. Requirements. Determine if the data are normally distributed. Under the QQ plot, you can paste 3 groups of data separately. To determine the population variances are equal, if the largest variance is at least 4 times as big as the smallest variance, we will conclude that the population variances are not equal. So then now my question is this I don't think the largest variance is at least 4 times. Are you okay?
See, and then my other question is, on part of the requirements for ANOVA, it says the data are normally distributed for each group using QQ plots. If you use QQ plots, it's not a bell shape. So that's why I was like, oh.
Okay, read the, oh no. Let me see something. Oh my gosh. Normality. Okay, variance. Variance. That's the word that I'm looking at.
What is variance? What is that? What does that mean?
Yeah, let me tell you. Variance means the fact or quality of being different or inconsistent. Probability theory and statistics. Variance measures how far a set of numbers is spread out. Okay, a variance of 0 indicates that all the values are identical. Variance is also non-negative. A small variance indicates that the data points tend to be very close to the mean and hence to each other, while a high variance indicates the data, remember I think it was like 1 or 2, okay, and that the data points are very spread out around the mean from each other, which means you have to do a QQ pop, because when you look at the line, that means you will have outliers, just like we said in here. But it says that there are no outliers that are bell-shaped. But that means they're using blocks.
My hair looks crazy too. Look at that. It's like somebody like pulled my hair.
Don't worry, my hair right now, my hair's like, there's no
like,
part.
Oh, somebody might see this and I look like somebody just came and like pulled on my hair.
It wasn't your kids.
No, that's the sad part. I just look like this.
Ugh. I'm
Well,
actually,
look, it
now
says-
I'm leaning towards no, because some of this doesn't even make any sense at all in the actual, like, description they're giving us. Bell shaped, because a lot of,
You're right. Well, you know it's a random sample, that's one of the requirements. Well, it's a simple random sample.
yes.
And then we know that it's bell shaped, so I guess, and there's no outliers, so that makes it normal. But then we need to know, are they independent samples? The populations of have the same variance. So when I go back here, it says the analysis of variance F statistics for testing equally of several means has this form. F equals variation among the sample means divided by variation among individuals in the same sample. Similar to the other test statistics, Z-score and T statistics, as F gets further away from 0, the greater likelihood that the value becomes an unusual result.
I think they're all independent, because there's a lot of variables that go into, I mean, if you think about it, you can't, like, the GPA thing, like, yeah, there's a certain, like, GPA. I'm guessing what they're trying to say is, being in a different apartment, does that give you better grades or not? But, like, that just sounds stupid. I'm sorry. You know, like, the whole, like, different apartments and GPAs thing just kind of throws me off.
So then it says descriptive statistics to use with data. Sample size, sample mean, and sample standard deviation from all samples. So do we have a sample size?
The sample size is 15 from each different apartment.
Do we have a sample mean? No.
I don't see one.
Do we have a standard deviation?
No, we don't have one specifically stated. So
Because then at the very bottom it says one of the
they do not know the true standard deviation of each sample. No, they do not have enough data. I don't know, maybe it's they have a total of 60 GPAs in all, but that just means, because their sample size is by group, right?
Yes.
So
well,
you can't have a total of 60, because it's
one thing we know is that we're always with this, we're testing for the mean. So we're not going to have the mean, because that's, well, we do we have the mean?
We have mean, but we're getting means of all means with ANOVA.
Right. But we don't have in the mean for this one.
No, we don't. All we have
So then you can't compare something, you can't compare means, and you can't do this test if you don't have the information.
If we don't have it, but they must have it somehow. Because we're thinking about them and what they have.
Right, but on here, it's giving you what information they know.
True.
And it's
It
asking,
actually
can
says
you
nothing
use
about
an
me.
ANOVA hypothesis to test to answer their question based
Okay.
on what you have here?
Right. So then I'm thinking we should go towards no, they do not know the true standard deviations of each sample because you need the mean in order to do that.
I was going to put, they know they do not have enough data.
Okay.
Well, because they don't have the means,
Okay.
right? They don't have the mean,
Right.
and then they don't have the standard deviation. So they're missing two pretty much crucial parts of how you can,
Get data.
right?
Okay.
That,
So then it's no. We know that.
well, we started off with yes, and then we went to no.
True, but the reason we had yes was because we didn't think about like separating the groups and saying that their means for groups are independent and then they come together to see if they are dependent on
Right.
each other. So okay. They know they do not have enough data.
That's what that's what I think. But at this point, I'm not sure about anything.
Yeah.
Okay, so then number 11, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an earlier trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years.
Oh.
Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with particular type of cancer. The research has committed what type of, or incorrectly used?
Okay. So we need to go to error types.
Yeah.
Okay.
So she rejected the null. So I put that she committed the type 1 error.
Okay. Type 1.
Unless,
This goes like way back, doesn't it?
yeah, it's
Lesson 9?
and
Lesson 9.
yes, it's way back.
Yeah, okay. Type 1 error was we never reject a true null hypothesis. We say that a type 1 error was committed. Assuming the null hypothesis is true, the level of significance is the probability of getting a value of the test statistic that is extreme. Okay. So fail to reject correct decision type 2. Reject type 1 error correct decision. Okay, I need to read that by myself here. they're statistically significant at the level of significance, which means consequently, she rejects the null. Okay, so she rejects it. She rejects the null. A type 1 error is committed. That makes sense, because it even says, here, I'm going to share my screen with you again.
Okay, what?
Okay, look.
Yeah, that's what I had.
Okay, good.
I put the first one, type 1 error.
Right, well, it can't be the other, like the last two, just because that's a lot of no p-value.
And we
Where
weren't
the
talking
heck
about
is it?
p-value at that
0.1.
point.
Yeah. Okay. Yeah, it's got to be 1 because she already rejected the null, because in this one, it says you fail to reject it if it's a type 2 error.
Mm-hmm.
Okay, good. I agree. Okay.
Okay, so then
Okay, we're on number 9,
we're on 12.
8, 12. Oh, wow, we're further than I thought.
Yeah, we still have a long way to go.
Don't tell me that.
If the level of significance A is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Goes up.
Correct.
So I put the last one. By reducing the probability of committing type 1 error, we increase the probability of committing type 2.
a type 2.
Okay, so
Okay.
13.
The nicotine content in cigarettes of a certain brand is normally distributed, the mean in milligrams, and a known standard deviation. The brand advertises that the mean nicotine content of its cigarettes is 1.5. Okay, that is the mean. But the measurements on a random sample, oh my goodness, I'm yawning. Okay, random sample of 100 cigarettes. You're yawning.
I know.
This spread gives a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? I'm echoing. To answer this test the hypothesis. Okay. At the 5% level of significance, you conclude, you should. So it states that it's smaller. Therefore, we, I guess, fail to reject again.
You have to compute it. Did you compute it?
Oh, dang it. Why? Okay. All right.
Hang on 1 second.
Okay. No, I have to connect to charger. Honey, do you have a calculator?
Probably one second.
Is that a blanket?
Yeah, the little string on the fan is not working, so it's like super cold. I can't. If I turn off the fan, I'll turn off the light, and you
Oh,
can't.
I see it, honey.
Right.
Okay, I've got a calculator. Oh my butt.
You want pillows?
No, good. Okay, I am. Do I need the? Oh crap. Okay. I said fail to reject.
It was, I put reject the HA.
OMG. I just need to read everything again. I'm just like.
Because you're going to use the Z formula.
It's the one I use, but dang it. I hate all of this. I hate it all.
I'm looking forward to ending this class.
Okay, I've got the Z formula, and that is that weird formula that's like super long, and I hate it. Okay, that's that X thingy with minus the mu over the standard deviation. Okay, so I have the 1.5 minus the 1. I'm guessing I'm using the 1.
Yeah.
Yeah, 1.5, right?
Mm-hmm.
Okay, good. Minus 1.5 equals divided by. No, I should do the second part. No. Let's see, it's 2. Let's go to the standard deviation. Holy heck. Okay. Standard deviation. 0.17 divided by.
Oh, when times again. Okay.
Give a sample mean of.
No, I'm just wondering what time.
I'm not given a sample size.
What now? Sorry.
For number 13, I'm not given a sample size.
Yeah, it's 100.
This is gonna sound really weird. Oh, there it is. Okay. Okay. Ten. Okay. Oh, I hate this. Okay. Okay, I got 1.764. So we reject it because it's greater than.
1 point, what, sorry?
I got that 1.764.
Okay, so you grab that and then remember we have to go put it on the applet.
Okay. In the applet now.
And then it's wanting the greater portion of it. So remember to just highlight.
Okay. Ugh. Got it. Okay. I put them in the bottom. Okay. Oh, and then the area or that p-value is 0.04, right? For you, 0.0389 or 3839.
Yeah.
Okay. Cool. Then that means, whoa. Okay, that means we reject it because it's larger. No. Which one are we? 5% level of significance. Oh my goodness. I hate rejections. I don't know. I don't know why it's reject.
Which one? Number 13?
Yeah, I don't know why.
I put reject A.
Because, oh, that's the alternative.
Yeah, you're doing that because on here you're trying to prove that it's greater than the 1.5.
Okay. You're trying to prove it. Okay. And it isn't, so you reject it. Which means that the null stated there is 1 point, that is equal to 1.5. Okay. All right. Because, I mean, it's not the same thing as saying fail to reject the null.
I don't know which one you're looking at, because
For number 13, you were saying the first one is reject the alternative hypothesis, but then you look
Yes.
down one and it says fail to reject the null hypothesis, which is basically saying the same thing as rejecting the alternative hypothesis.
yeah, but you're always looking at the alternative.
Oh.
Because that's what you're trying to prove.
Okay. All right. Okay, you would
The
like.
first one is telling you the mean equals 1.5. Like that's what they have.
Okay.
But then the other one's telling you what you're trying to prove is that the mean is greater.
Okay. I agree with you. I'm just like, okay. All right. Got it. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So means. Testing if means are different. You have two different groups. I'm guessing it is a paired sample t-test, or yeah, because there's not multiple groups. I mean, there is, but it's not enough to say ANOVA. So it's paired, right?
I put independent samples.
Oh, because it's male and female.
Yeah, and like whatever one does, the other it doesn't affect the other one.
Right, that makes sense. Oh, I feel like I know this too. Oh, I feel like I sound dumb. Okay.
Oh no, you're not.
Okay. An
You're
educator,
probably just tired.
maybe. An educator is interested in academic achievement by males and females. Ugh. Okay, with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? Independent? Clearly. Okay, independent because of the first one, the brother and sister are separate people who make their own choices. So the brother's academic achievement shouldn't depend on his sister's academic achievement.
Well,
Include in the
put
study tells you nothing about which sisters are included in the study. Huh. Okay. What'd you put?
I put dependent sampling, the last one. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study. So you can't just do the brother. It was kind of like that female one with the
Yeah.
wife and the husband. You can't compare the husband's income without having the wife in there. So same
Right.
thing here. You can't compare his academic achievement with his sister without including her in the study. So they're dependent on each other.
Mm-hmm. Okay. Independent. Okay. Mm-hmm. Got it. All right. You're right. Okay, he needs to select couples for his sample, so whether a particular wife is included depends on whether her husband is included. Okay, because we got that one wrong. I remember that.
Yeah.
Okay, that makes sense. Okay. All right. Now 16. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon of each sample. The researchers would like to construct a 95% confidence interval for the mean dissolved organic. Oh no, do I have to do this calculation?
It doesn't really matter. You just have to know which one of those confidence intervals you're going to use.
Okay. Of the 4 types of confidence intervals listed, which is the appropriate for this situation? Okay, for 16 and 17. Okay. All right. I'd like to construct organic carbon level in the field. Open the data file dissolved. Okay, use this information. 16. Of the 4 types of confidence intervals listed, oh my goodness, which one is appropriate for this situation? Okay, we do not know the standard deviation or the mean, right?
Yeah, which one did you pick?
I chose confidence interval for mu when sigma is unknown.
Yeah, that's what I picked.
Okay.
And then I was like, well, what about the following one? Confidence intervals for the mean of differences using independent.
Using
But
dependent samples, but those are no.
and the only reason I thought about that was because it says 95% confidence interval for the mean dissolved organic carbon level in the field.
Right. That makes sense, but I think it is confidence interval for you. The
That was
mean
my first
dissolved.
thing to put.
There's really no differences though. I mean, the mean of differences, mean dissolved carbon level in the field. Ugh. All right, I like our first choice.
That's what I'm keeping. I mean,
That's what I'm keeping. Okay. Uh-oh, this is actually opening it up and looking at the lower and upper levels.
yeah, so let me see if I still have that one up.
Okay.
This is for
Oh, direct flight. No, I don't have that one. But
I know how
I
to
got,
do it.
huh?
I know how to do it, honestly.
Yeah, I got the last one, 11.168 and 15.2.17.
Okay. Okay. Okay, what'd you go for 19, since I know I'm skipping one, but oh. This one.
19 I got,
The negative 210
no, I got negative 423 and
and the 551.
54.17.
Okay. A random sample of Hummers for sale. Okay. We're taking listings at cars. We want to know if there's difference. Since we are. I am tired, huh? And Hummers for sale in New York. 95% companies involve true difference of mean listing prices between two cities. Okay, so this one is 3, confidence interval for the mean of differences using dependent samples.
That's what I got.
Okay, because this is kind of like that wife thing again, huh? You can't include, you have to include one or both if you're going to do that. Does that make sense?
Well, that's what I was thinking. I mean, they really don't, it doesn't really matter how many cars they sell. Well, no.
Well, that makes sense.
Well, if you're doing Los Angeles and New York, you have to. I get confused on this one.
Yeah.
That was my first reaction to use independent, but then I'm like, are they? Well,
Well,
you have to have those two, specifically those two, in order to compare prices.
right, and they're groups, group 1 and group 2, and I remember putting in the dependent list for the SPSS group 2. I think you have to do confidence interval for mean differences using dependent samples.
I think so
I mean,
too.
it's talking about different.
And that's that is what I did.
Yeah. Okay, but here it says confidence interval for the difference of means. And then there it says confidence interval for the mean of differences. In the question it says for the true difference of mean listing prices. Difference of mean, differences of, or difference of means versus mean of differences.
So maybe it is the bottom one.
The independent one.
Yeah.
Did you change it?
Mm-hmm.
Okay. I don't know. I'm just reading, and I think
Right.
the wording, like we said, could be like, that could be it, you know?
Mm-hmm.
Yeah.
Okay.
Many studies have suggested there is a link between exercise and health, stress the bones, and causes them to get stronger. Okay. One study examined the effect of jumping on the bone density of growing rats. There are 3 groups. Okay, 3 groups. A control with no jumping, a low jump group, and a high jump. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The rats were selected at random. Okay, so there's a random sample. There's 3 different groups. There's like a variable which is, I guess, 60 centimeters. There is a level of significance. Okay, determine if the mean levels. So this is comparing means, and I think this is ANOVA, isn't it?
That's what I put, yes.
Okay, good. Calculate, dang it. Okay, calculate the test statistic. I can't do that right now.
I got 7.978.
7 point. Okay. The only reason. Okay. All right. I just need to. I just need to tell her I need to get that working. Okay. Give the p-value. What'd you get? Was that 0.002?
Yeah.
Okay. It was a pure guess.
Mhm.
Which of the following best expresses the conclusion of this test? Okay. It's less than the level of significance. Therefore, there is sufficient evidence, right,
Mm-hmm.
to conclude that the bone density of all three groups is about the same.
I put bone density of at least one of the groups is different from the bone density of at least one of the other groups.
It has to be at least one if it's an ANOVA test,
Mhm.
right? Okay, that makes sense. Pressures of supply and demand act directly on the prices for an airline ticket. Seats available. Seats on flight do not sell well. Okay. A study. Difference in the mean cost of an airline ticket purchased 9 days in advance of scheduled flight compared to the purchased only 14 days in advance. There's only two different groups. Okay. One. Okay. What is the correct hypothesis test for this situation? There's only two groups, so it is a dependent samples test.
That's what I got.
Okay, good. Calculate the test statistic.
I got 1.685.
Okay. And for the next one, I'm guessing you got 1.74.
No, I got 0.096.
96.
Mhm.
Okay, which of the following best expresses the conclusion of this test? It is lower again, so there's sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days.
Yeah, that's what I got.
Okay. Okay. And that's all of them. Do we feel comfortable?
Yeah.
All right, let's just turn it in, I guess.
Okay.
I'm pressing submit.
Yes.
Oh, we got a B minus 82.
Wonder what we missed.
Number 2, and number 5, and number 6, and 10. Oh, number 10 was bell-shaped with no outliers for that ANOVA one.
Oh man.
Oh, and then the 13 for the reject the 8, it was actually reject the null. We were both wrong.
Oh, the first one?
Yeah, for the 14, number 13.
See, I got confused on that one.
Well, I knew it. Okay. I know we're both wrong, but I felt like it had something to do with the null. I just wasn't sure if it was fail to I thought it was fail to reject, but we were both wrong. That was okay. And then
6.
everything else is right. Okay, so for 6. What one was the 6th one again?
What was what? Sorry?
Oh, 6 was just numbers.
Yeah, but remember it was like how to compute them.
Yeah,
And I
yeah.
wasn't sure, I just did that and I was like, oh well, that seems about right. But
Okay, well, we'll figure that part out. Okay, and then 5.
5.
Obtain the balances of 90 bank customers rather than 30. 90. Why would we? Why? That's so random. That's so random. So it has to do with sample size. Increase the sample size in order to produce a higher confidence interval or with a smaller margin of error. Wait,
It was
yeah.
90.
Obtain the balances of 90 baked customers rather than 30.
Oh, it has to be a bigger sample.
Yeah, so if you want, okay, so then I'm guessing if you want the smaller margin of error, then you have to obtain a sample size that's larger.
Yeah.
Okay. All right. And then number 2, or number 1, number 2, given 90%. Oh, yes! Okay, so remember, we are always 90% confident that the true mean heart rate is between 45 and 105.
So it's a true mean?
Yeah, it says we are 90% confident the true mean heart rate is between 45 and 105.
Sorry, I was just getting to that one. I thought for some reason she said something about the true mean that is not. Oh, yeah.
I chose what you chose, so we got the same answers and we got the same score, but
Yeah.
some of these, I mean, we tried, man. We tried.
Yeah, that's true.
Okay, number 10. So that's interesting. Yes, it is enough that the data are bell-shaped. We went from yes to no, like constantly. Okay, yeah.
I think we just kept second guessing ourselves and second guessing ourselves.
That was one we spent a lot of time on.
Oh well.
Okay. All right. I gotta get going though. Okay. It's a good thing.
All right.
So.
Well, when are you doing the exam?
Here, I'm gonna go stop the